Hello friends, today we will see the next examples from problem set 3. Look at this figure. In this figure there are two circles. A circle with center x and a circle with center y touch each other at point z. We have to prove XA segment is parallel to BY. It's a very simple example, very easy example. You can solve it easily. See, in the circle with center x, XA and XZ are radii of the same circle, therefore they are congruent. If these two sides are congruent, the opposite angles of these two sides are also congruent. That means these two angles are also congruent. Let each angle be of a degree. Now see, if this angle is A, then this is the vertically opposite angle of this angle XZA. The opposite angle of XZA is BZY. Therefore, this angle BZY is also a degree. Now, in the circle with center Y, here are also YZ and YB are the radii of same circle. Therefore, they are also congruent. If they are also congruent, then the opposite angles of congruent sides are also congruent. That means if this angle is a degree, then this is a congruent angle of this angle. This is also a degree. Now see, angle XAZ and angle YBZ are alternate angles. Hence, XA is parallel to BY. The example is given in the form of activity. You have to solve by using this ideology in the activity. We will see the next example. Now look at this figure. Here the center Y of a bigger circle is here, and this one is X. It is the center of smaller circle. These two circles touch each other at point Z. AZ is a line intersecting the smaller circle at point A. You have to prove that BY is parallel to AX. See, I will not going to solve this example here. It is also very simple example. You have to solve. Just I will show how to solve this example. See, if we join XZ and if we join YZ, these 3 points are collinear because internally touching circles or externally touching circles and their touching point are collinear. Hence, this is a straight line. Now, this triangle BYZ is a triangle and AXZ is also a triangle. If we want to show these two lines parallel, then these angles are corresponding angles and they should be congruent. We have to show that these two angles are congruent. But first come to this smaller triangle XAZ. AX is congruent to XZ. Therefore, this angle is a degree and this angle is also a degree, because if the two sides are congruent, their opposite angles are congruent. Now come to the bigger triangle YBZ. YB is equal to YZ because the radii of same circle. Hence, this angle is congruent to this angle because opposite angles of congruent sides are same. Now see, this angle is A, this angle is A. Both the angles are congruent, but they are corresponding angles because this BZ is a transversal. Hence, this line AX and BY are parallel. Now look at this example. In this example, here a circle with center O L is a tangent which touches the circle at point P, RS is a chord, and OP bisects the chord. Therefore, it is perpendicular to this. Now see, Q is the midpoint of OP. Therefore, OQ is equal to QP is equal to OP upon 2. Now, here forms the right angled triangle. In this triangle, OR is a radius. OR square is equal to RQ square. If RS is 12, then RQ is 6 and QS is 6. This perpendicular on chord bisects the chord, therefore this is 6. This is OP. OP is equal OR is equal to OP radii of same circle. Therefore, OR square is equal to RQ square plus OQ square. OR square is equal to 6 square plus OP upon 2 bracket square. OR square is equal to 36 plus OR upon 2 bracket square, as OP is equal to OR radii of same circle. Therefore, OR square is equal to 36 plus OR square upon 4. Now multiply by 4 to each term of the equation. 4 OR square is equal to 144 plus OR square. Now 3 OR square is equal to 144. This OR square gets subtracted from the left side. Now OR square is equal to 144 upon 3. OR square is equal to 3 4s are 12 and 3 8s are 24. Now OR is equal to under root 16 into 3. OR is equal to 4 under root 3.